Hello everyone, today we're going to be solving Project Euler's problem 4, which is titled Largest Palindrome Product. This problem states that a palindromic number reads the same both ways. The largest palindrome made from the product of two two-digit numbers is 9009. Our task is to find the largest palindrome made from the product of two three-digit numbers. So most people would solve this using brute force. They would create an embedded for loop like this that checks through all possible two three-digit number product combinations, and then they would check if it's palindromic, assign it to a largest variable until they find the biggest one. However, if I'm correct, this is 900 squared calculations from these loops, which is wildly inefficient compared to the solution that I have come up with. Okay, so we can all agree that there are more six-digit products than five-digit products using these conditions, right? Because there are more six-digit numbers than five-digit numbers. So we're going to look at the structure of a six-digit palindromic number. It'll look like this, right? And we can expand this with multiplication that moves the numbers to their digit places, unit places. So we can have 100,000A to move it to the 100,000s place, 10,000B to move it to the 10,000s place, and so on. And what we're going to do from here is we're going to combine like terms, right? So we're going to get 100,000A, 100,001A, plus 10,010B, plus 1,100C. All of these numbers, all of these multiples have 11 as one of their factors. So we can factor out 11, and we'll get 11 lots of 9,091A, plus 910B, plus 100C. This factor of 11 is important because it means that for a six-digit palindrome that comes as the result of the product of two three-digit numbers, at least one of these numbers has to have a factor of 11, which will massively decrease our search space, right? You might be noticing that I have excluded five-digit numbers. Technically, there could be no six-digit palindromes at all in case the largest palindrome would be five digits. However, the actual maximum is a six-digit number in this case, so this is a safe optimization to do here, although it's not universal, right? So we're going to start out making a function to check if a number is palindromic. This is very standard, so I'm not going to talk on this too much. However, I want to draw your attention to this part right here. Nope. You might have not seen this before, and just in case, I'm going to explain what this is. So string slicing in Python has three parameters: start, stop, and step. This is the one that most people don't know about, although it is very useful for this problem. So essentially what this does is it sets our step to be -1, and since we haven't set any values for start and stop, because our step is -1, Python has automatically set the start to the end and the stop to the beginning. So we can run through our number backwards like this. It will reverse the number, essentially. It will reverse the order that the digits come in. So it's a good way of checking this. It's optimal. So now we're going to go on to generating our products. So we're going to make a largest variable to store the largest palindrome, and now we're going to create a loop that steps backwards. I'm going backwards because I want the biggest products first. Because once we find a strong answer, we can just cut off useless work, right? And in this loop, we're going to do if a modulus 11 equals 0. Now the reason I've done this is because of the palindrome property that I just proved, which is that one of these numbers involved in this product has to be a factor of 11. And if this is the case, we're going to set B star equal to 999. B doesn't need any restriction if A is a multiple of 11, right? And we're going to get step equal to 1, we're going to let it step down by 1 each time. B can be any 3-digit number in this case, right? Else, because if A isn't divisible by 11, then the palindrome can only still be divisible by 11 if B is. So we're going to say that B star equals 990 because it's the largest 3-digit multiple of 11. And we're going to do step equals 11 because we only want B to be a multiple of 11 in that case, because one of them has to be a multiple of 11. So now we're going to set the B loop. For B in range, B star minus 1 minus step. Now, we've done this, we've done this part where it stops at A, so we don't repeat pairs. We only want to count one lot of each pair to be optimal, right? So, for example, if we check 999 times 996, then we don't also want to check 996 times 999. That's just a waste of time. We'd be doubling each operation, which is useless, right? So, here we're going to calculate the product, A times B. And then we're going to do if product is less than or equal to largest, break. Because if the product is less than our current largest palindrome, we don't care about it. We don't need to do anything with it. That's just, yeah. And then if the product is greater than the largest, we're going to check if it's a palindrome. And if it's a palindrome, we're going to set largest equal to product. Right? And this should be the program done. We should just be able to print largest, and this will work. Let's see. And there we go. We get 906, 609. If we read it backwards, 906, 609. Perfect. Thank you guys for watching. I'll see you in the next one. Bye-bye.